Welcome to my channel, and here we are going to be looking at objective questions on technical drawing, and the questions are combined questions of Waec and Neco technical drawing questions, and we are taking it topic by topic. We are taking it topic by topic in technical drawing. So now we are focusing on polygons, questions on polygons. So we start with question 1 as we have here. Wherever I need to explain, I will explain, and wherever I need to give direct answer, I will give answer to it, then we move on. We have about 23 questions to answer here, different questions on polygons when it comes to its objective questions. Now, question 1 says that the interior angle of a regular lunagon is 140 degrees. So the interior angle of a regular lunagon is 140 degrees. The lunagon has 9 sides, and if we are to get the exterior angle, we divide 360 by 9, and that will give us 40 degrees. Then we have to subtract 40 degrees from 180. Then that gives us 140. So the interior angle of a regular lunagon is 140 degrees. Then question 2 says that which of the following polygons can be constructed using 60 degrees set square and 80 square? That is option B. Hexagon is what is that polygon that you can construct using 60 degrees set square and 80 square. So the answer is option B in this case. Then question 3 says that which of the following is not a reentrant polygon? Which of the following is not a reentrant polygon? So option C is the answer to this question. So this polygon here in option C is not a reentrant polygon. Okay. Then question 4, we have to use this diagram to answer question 4 and 5. And question 4 says that what type of polygon will be constructed in the circle above if line OP is the radius? So the answer is a pentagon. The answer is a pentagon. So if you have to construct a square, that's a 4-sided polygon, we use this point 4 as center of the circle that will give us a square. And if we have to construct a 6-sided polygon, that is hexagon, we have to use this center 6 as center of the circle that will give us a hexagon. Then if we have to construct a 5-sided polygon, which is a pentagon, we have to make use of this point O with radius OP. Then we draw a circle that will give us a pentagon. That's a 5-sided polygon. So the answer to this question is option D, which is a pentagon. Then question 5 says that what is the value of angle X? So the value of angle X here is 54 degrees. So that is option C is the answer to the question. Then question 6 says that which of the following pairs of polygons contains 45 degree and 60 degree exterior angles respectively? So the answer to this question is option C, octagon and hexagon. Octagon and hexagon. The exterior angle of octagon is 45 degrees, while the exterior angle of hexagon is 60 degrees. So option C is the answer to this question 6. Then question 7 says that if the exterior angle of a regular polygon is 72 degrees, the polygon is a pentagon. That is option E is the answer to this question. So the exterior angle of the pentagon is 72 degrees, while the interior angle is 108 degrees. So let's take note of that. Then we move to question 8, which says that a polygon with internal angles of 135 degrees is a polygon with internal angles of 135 is. So the answer to this question here is, I think that answer should be octagon. So that is the answer. So if we divide 360 degrees by 8, that gives us 45. Then 180 minus 45 will give us 135. So option B is the answer to this question. So octagon is the answer to this question. That's option B. So its interior angle is 135 degrees. So let's take note of that. Then question 9 says that line PQ and QR in figure 12 are two sides of a regular pentagon. That is option A is the answer. I've said it before that the exterior angle of a regular pentagon is 72 degrees. So the answer to this question 9 is option A, which is pentagon. Then question 10 says that the value of each exterior angle of a regular decagon is the value of each exterior angle of a regular decagon is 36 degrees. The answer is 36 degrees. So all you have to get the exterior angle of a regular decagon or of any polygon is to divide 360 degrees by the number of sides. So now that we are dealing with a decagon, that is a 10-sided polygon. If we divide 360 degrees by 10, that will give us 36 degrees. So the answer to this question is option D. Then question 11, a polygon with 8 triangular faces is called an octahedron. An octahedron. A polygon with 8 triangular faces is called octahedron. So option D is the answer to this question 11. Then question 12 says that the sum of all exterior angles of a regular octagon is 360 degrees. That is option D is the answer to this question. So the total exterior angle of any regular polygon is 360 degrees, be it octagon, be it nonagon, be it hexagon, or pentagon, or heptagon, whatever any regular polygon that we are talking about, the sum of all its exterior angle or angles is 360 degrees. So let's take note of that. Then we move to question 13, which says that the purpose of construction in figure 9 is to obtain an inscribed pentagon. Is to obtain an inscribed pentagon, which is option A, is the answer to this question. So how did I know that the answer is pentagon or this option A? How did I know? I will come back into this diagram and we count the number of divisions that we are dividing this line into. Okay, so we have 1, 2, 3, 4, 5. So since we have 5 equal divisions on this line, so this the type of polygon that we have to construct, that we have to inscribe in this circle is a pentagon. That's a 5-sided polygon. Then question 14 says that which of the following regular polygons can be constructed with a 45-degree set square? So the answer is octagon. So we have treated something similar to this before. So the answer is option D, an 8-sided polygon. That is octagon, is the one that we construct with the use of 45-degree set square. Then question 15 says that what is the value of each exterior angle of a regular dodecagon? So what the first thing I need to know is that a dodecagon is a 12-sided polygon. A dodecagon is a 12-sided polygon. So if we know the number of sides to be 12, then we divide 360 degrees by 12, and that will give us 30 degrees. So the exterior angle of a dodecagon is 30 degrees. Is 30 degrees. So 360 by 12 gives us 30. So the exterior angle of a dodecagon is 36 degrees. Okay. Then question 16 says that if the total interior angles of a regular polygon is 540 degrees, the name of the polygon is a pentagon. The name of the polygon is a pentagon. Okay, so the formula that we use to calculate the sum of interior angles of any regular polygon is n minus 2 times 360 degrees, and that will give us 550. That means we have what? If we have 5 minus 2, then that will give us 3. Then 3 times 180 degrees will give us 540 degrees. So the answer to this question is pentagon. That's a pentagon that had the sum of all interior angles to be 540 degrees. Then question 17 says that if each exterior angle of a regular polygon is 60 degrees, the name of the polygon is hexagon. That is option C. So the value of each exterior angle of an hexagon, that is a 600 polygon, its value is 60 degrees. The exterior angle is 60 degrees. Okay, so let's take note of that. Then question 18 says that the value of each angle of an equilateral triangle, the value of each exterior angle of an equilateral triangle is 120 degrees. 120 degrees, because each interior angle of an equilateral triangle is 60 degrees. Then if we are to get the exterior angle, we have to subtract 60 degrees from 180 degrees, and that will give us 120 degrees. So the answer is option C. Each exterior angle of an equilateral triangle is 120 degrees. Then move to question 9 and 19, which says that the sketch shown in figure 2 is a method of constructing a polygon. A method of constructing a polygon. We have seen something similar to this up there. Okay, so the answer is option A here. We use this method to construct a regular polygon. Then question 20 says that the total exterior angle of a regular pentagon, is 360 degrees. I've said this before. Any regular polygon, add the sum of all its exterior angle will be 360 degrees. Then question 21 says that what is the external angle of a nonagon? What is the external angle of a nonagon? So the external angle of a nonagon is 40 degrees. So all you have to do, divide 360 degrees by 9, and that will give us 40 degrees. So option B is the answer to this question, as each exterior angle or external angle of a regular nonagon is 40 degrees. Then question 22 says that the value of each exterior angle of a regular pentagon is 72 degrees. We have come across something like this before. So the answer is option A. So each exterior angle of a regular pentagon is 72 degrees. Then the last question here says that which of the following polygon has each interior angle as 120 degrees? So the answer is hexagon. So we have also checked about something similar to this before. So the answer here is option C. That is the answer to question 23. So it's as simple as I've done it here. All you have to do is to pay attention in the class while you are being taught and read your notes. So once you are able to do that, be able to answer similar questions like this with ease. Thank you. Keep on practicing, and God bless you.